All right. Hello, everyone. We're so excited to be here. I'm David Sullivan, founder and CEO of TridentInnovations.
My name's Adrian Britt, and I'm the Chief Science Officer.
My name is Thomas Jarvis, and I'm the CTO.
We're here with a portable solar-powered water desalinator for immediate use in natural disasters and emergency relief with an MIT patented process that is exclusively licensed to us. We're going to be market disruptors and reinvent the way the world interacts with water on the go. Over 3 trillion people are at risk of not having water every single day, and it's getting worse every day. To exemplify this best, we have to look at the 2010 earthquake in Haiti, where a 7.0 earthquake crippled the nation's water supply. On the first day, the U.S. Navy alone brought in 100,000 gallons of bottled fresh water. By the end of the 7 days, it's estimated that nearly 4 million gallons of bottled fresh water were brought in just to stem the problem. Despite this and relief organizations' best efforts, to this day, 31% of the country does not have reliable access to clean drinking water. This has led to 530,000 cases of cholera and 7,000 deaths. Of those 7,000 deaths, 61% of them are in children under 5. This is clearly unacceptable, and our current solutions are not solving the problem. On top of this, the cost of water to be provided to Haiti and of repairing the nation's water supply has totaled nearly $10 billion and is still increasing to this day. Current solutions are not up to the challenge.
So what is TridentInnovations' solution to this gap in the marketplace? We have designed a portable desalination device that utilizes a new technology made by MIT called shock electrodialysis. Our device will be the most lightweight desalinator available on the market. Weighing in at about 40 pounds, any single individual can easily transport this device wherever it's needed. Furthermore, thanks to its streamlined design, anyone who really needs to use this device in a disaster area can do so both quickly and efficiently. The actual parts it takes to manufacture are very inexpensive compared to existing solutions, and it has a 2-year lifespan with continuous running, which makes it a prime candidate for mass production. And shock electrodialysis is an incredibly scalable technology, which means it does not have to end with this device here.
So why should Trident be the leaders with this new product? Well, looking at our team, we have David Sullivan, our CEO. David Sullivan has a background in environmental studies, and is the market coordinator for a DC startup. Next, we have Adrian Britt, who also has a background in environmental studies. Adrian will also have a master's in biology in the future and has lab work with purifying water. For myself, as a computer scientist, I have hardware and software experience. Looking at our mentors, we have Scott Sklar, the president of the Stella Group. Scott has decades of experience working with the government and environmental policy. Next, we have Ed Martinez, who is our mentor here for the competition, and he has startup experience with international development. Next, we have Mark Sullivan, who's a principal at Ernst & Young. Mark will guide us in our marketing and financial operations. And finally, we have Peter LaPluma, who is a PhD professor here at the university, and he will assist us in our research and development of our product.
So you may be asking yourself, how does this technology actually work? We have taken a generally incredibly complex system and condensed it down into 3 simple steps. The first of which is prefiltration. Prefiltration takes the water from whatever dirty water reservoir that you are taking water from and filters out all of the macro particles. After those macro particles have been filtered out, we go through a water reservoir that is electrified. The electrification comes from solar energy collected by our solar panels, and it creates a barrier in the water reservoir that separates particles such as metals and salts and makes them come out through the brine outlet. Conversely, fresh, potable water comes out through the freshwater outlet. This device is entirely powered by solar electricity, but what really sets us apart from the rest of the competition is that besides desalinating, we also purify water, killing 99.9% of all pathogens existing in the water. The device creates enough water for an entire family at about 1 gallon per hour and has a 76% retrieval rate from salt to fresh water, which is currently more than any other product available on the market.
So what are the current solutions we have in the market right now? Well, first we have the Aquifer 200, which is an RO system, or reverse osmosis. And reverse osmosis pushes water through a series of filters. This process is energy intensive, and due to its complexity, it is heavy and expensive. Next we have the Aquamate, which is a type of solar still. Solar stills use the power of the sun to evaporate and desalinate the water. This process is unreliable because it requires a massive heat source at all times to work. It's also inefficient because evaporation is a slow process. And finally, at the end of it all, it doesn't even purify the water. You have to take the water and put it through a purification process before you can even drink it. The last current solution is actually bringing bottled water into these areas. This system is limited because you can only carry so much water at a time. It costs a lot, and you need distribution centers to actually pass out the water. Our product meets the needs of this market, looking at affordability, efficiency, portability, and purification. We talked to 25 industry leaders about their experiences and needs in the portable desalination market. We primarily focused on relief organizations like UNICEF, USAID, and the Red Cross, for they're our primary customers. We then reached out to organizations like Doctors Without Borders and the Peace Corps, because they use desalination in the field and will help us establish our functionalities we need for our product. And finally, we surveyed manufacturers and distributors like Catadyne and West Marine to establish our market value. There were an overwhelming response from these industry leaders that they would like a product that is more efficient and cost-effective than what we currently have.
Trident Innovations has come up with a 5-step process and life cycle for each device that we put out. Using our partnered manufacturer, we will be leveraging existing distribution channels and industry leader connections with relief organizations. These relief organizations will, in turn, bring our device into disaster areas for use by those who need it most. And finally, thanks to the modular nature of our device, any critical component can be easily replaced, which puts our product in the field much longer than already existing solutions.
But how are we going to get our product to this point? We're currently finalizing a conditional exclusive license with MIT that will make Trident Innovations the sole creators of a shock electrodialysis powered portable desalinator. After this, we're acquiring a utility patent to protect the intellectual property of our device. Once we acquire this, we're getting 2 engineers full-time for 6 months to help us create 5 prototypes that we will then bring into critical areas for our alpha test. During this alpha test, we're going to make sure that our product is reliable, is meeting the market need, and is efficient at what it does. Once we gather this data, we're partnering with a manufacturer to create 100 beta prototypes, which we'll then bring back into these same areas for an extended beta test to ensure reliability, feasibility, and distribution channels. After this, we're going to do full distribution and manufacturing. What's it going to take to get us through alpha stage? Acquiring a patent for our device will be $25,000. The 2 engineers for 6 months will be another $100,000 to create high-quality products. Next, legal fees for licensing, NDAs, and patent consultation will be $15,000. And finally, travel, materials, and testing will be $10,000 for $150,000 to get us through alpha stage. But what does Trident Innovations look like in 5 years? Well, when we go to full distribution and marketing, we are going straight to the critical areas that we tested, such as the Caribbean, Southeast Asia, and India, where our product is needed the most. But over these next 5 years, we're creating new iterations of our fully scalable technology for use in military, recreational, well reconfiguration, and near water housing projects, so it doesn't stop here. As you can see, we are growing exponentially as it keeps continuing, and over 5 years is not the limit. The need for water in this stale marketplace allows us to reinvent the whole marketplace of this $23 billion market. So it's clear that water is going to be the new oil in the future, and current solutions are simply too slow and too expensive to keep up with demand. We will be the pioneers in portable water desalination with our MIT patented process that's exclusively licensed to us, alongside our innovative design and our customer-centric engineering, we have made it our job to protect water security both today and in the future for anyone who needs it most. At Trident Innovations, our mission is to make sure that no one goes without water for another day. Thank you so much for your time. We really appreciate it.
I love this. I mean, I agree. Water is the new oil. Very, very smart. Question is, so you said that this purifies a gallon per hour? Yes. Is your also idea maybe to like provide these to a village or to like how many people can use one of these rather than obviously you're not going to just like give it per family, and then also I'm thinking in my mind. You should look at like the Global Alliance for Clean Cook Stoves, which is a public-private partnership between the State Department and the UN Foundation and a bunch of different countries who are looking to provide cleaner cooking solutions. And so it would just be interesting to see the model of scale up and how you guys intend to kind of.
Absolutely. So the average person needs about a 3/4 of a gallon per day. So in just 4 hours, we can easily provide enough for 5 people with each device. You have on average 8 hours of sunlight per day, which means each device can provide from 10 to 15 people in an emergency scenario. But in ideal situations, since our device does last longer than current solutions for 2 years, about 10 people per day on full running time. Sorry.
Super quickly, can we see the product?
Yeah, this is a design. Yeah, this is just a design prototype, just for pure.
I didn't want to interrupt. I just
Yeah, just pure. People can understand. Yes, Amit?
Yeah, so with the patent from MIT, the technology, I guess I'm not 100% clear what exactly are you licensing from them, and two, why can't MIT just go to market themselves? Why are they doing this with you?
Great question.
Can you go back to that slide that has the flow with the technology piece? So just to play off of Amit's, where along this chain is the exclusive license?
Yes. So
And, so I'm just piggybacking on him.
absolutely, this is a great question.
And how did you come across it? Like, yeah.
That's great. So yeah, the kind of the history of what happens. So the shock electrodialysis part happens in this water separation reservoir, which Adrian will be more than happy to go into some more details if you guys are interested in that. However, so that is the part that is exclusively patented. The reason MIT is not doing it, this technology came out 2 years ago. The whole team was final year doctoral students. They graduated and they've not picked up this project at all. Their current focus with this technology is for large-scale fracking wastewater production, and I've been in contact with MIT for the past year, and they are working with us to help us develop this technology because they want more hands on deck to get this technology out there because it is revolutionary.
How did you come across it?
Absolutely. So I was listening to a TED Talk about the crisis in water, and I realized that there has to be a better solution. So I started, doing scholarly research, and I found after digging on, there's a ton of RO, I found shock electrodialysis, looked it up, saw nothing has happened no news on it since 2014, and so I reached out to MIT and said, hey, I would love to be a part of this. What's going on with it? And they said, unfortunately, we don't have anyone working on this technology. If you would love to, we have people who are interested in this, and we'll start working on it.
I have a question.
Absolutely, Peter.
Do you know how many gallons per day Charity Water gets from one of their wells?
Unfortunately, I do not. Yeah.
Is this so? I think we can give the feedback later. I think because your entry was really compelling, which is disaster relief, right?
Yeah.
Which is not a one-to-one. It's not a linear process of getting water out, right? It's like a many-to-one problem you're trying to solve. So understanding the use case better, you had REI as a distribution partner, and you had the Red Cross.
Yeah.
That is a camper hiker, and then that is disaster relief, and those are two different users still getting purified water, right?
Yeah.
So it would be helpful to understand the use case, who exactly is a customer here, and how it plays well with charity water, right? Guys that are drilling wells to get an evergreen supply of water at a massive amount of scale.
Or maybe it's a partnership.
Absolutely,
Right.
yeah. Sorry if that's following.
Yeah, so my question, because you had the year by year, how many units you're predicting to sell. If you were to get into, a contract, let's say with American Red Cross, how many, or when you talk to these organizations, did they give you a number of how many they would buy per year?
Because our product is still in development stage, we are currently finalizing exactly the costs of how much each one of these would be. And because they're working inside constrained budgets, they wanted us to come back and follow up with them as soon as we kind of had a more finalized idea of
Got it.
that.
So the units would be dependent on how much you guys would charge. Got
Exactly.
It. Got it.
Exactly.
Also, when you're looking at competitors, like the Aquifer 200 costs $22,000 for one unit. So the idea is like if you put that sort of money into our much cheaper product, you could get 22 versions of our unit, which should be a
Yeah.
lot better.
I think the competitive set, I think you should actually think less about this product. Again, depending on who the user is, because I can get a well built for $4,000 at Charity Water. Or like an individual donation gets you $3,800 gets you a well.
Yeah.
And so, right, I think that's kind of what you're competing against in some capacity.
Exactly, and that's why there are certain technologies that are stationary that do outcompete our product, that are large scale RO. However, where ours shines is its portability that current solutions are not allowing, because in disaster areas where certain families are distant from certain wells and can't get there every day and can't carry the water back to where they need it, that is where ours shines. Absolutely, Anastasia.
Yeah, and that's why I think like even the focus on disaster relief, refugee response, like UNHCR partnerships, anything with the UN, and also U.S. government. Which is why also I bring in, again, the Global Alliance for Clean Cook Stoves, because it was a great partnership between state and some others. But I see, DOD really getting a lot of these.
Yeah.
So what's the cost per unit? I don't know if it's
Estimated right now, yeah. Because it's just our current estimations, we're estimating $550 per unit to be produced. At around 1,000 units, that's around the cost that we've estimated. Until we've finalized design and exact products needed inside of it, that is subject to change, but it should be around that time. Hopefully, we're highballing that, and hopefully it decreases.
And you're selling it for?
Once overhead comes in on our company, that is another thing on how much we need. It would probably be $800 after overhead, as we want to get this out there initially.
So all of the customers you mentioned are a pain in the ass to work with.
Yes.
How do you de-risk that part of this model? Because especially in like disaster relief and stuff like that, like they're just, I've dealt with it before.
Yep.
A lot of different ventures. It sucks.
So, like Thomas said, Catadine is a large-scale manufacturer and distributor of water solutions. They have existing relationships with relief organizations and have contracts. They're the one who uses the Aquifer 200 that we had on a previous slide. We have talked with them, and they would be our distribution channel, and they would be distributors of our product. Because, like you said, it is very difficult to acquire some of these.
So you would sell your product to someone who also has a product that it would compete with?
Absolutely, yeah. They would be our distributor of our product. Yes.
And they sell multiple products.
Yeah,
So ours would be another one, and anyone could buy it in theory after they're selling it.
Yes.
So today they sell multiple products.
Yes.
Okay.
Yes.
And who do they sell? Who does the distributor sell to right now?
They sell. You can get it recreationally. They have it fully on disaster relief. Like theirs was used in Hurricane Katrina, not to much success, but they do have existing relationships with FEMA and Red Cross.
And what is the current market size? It seems like there are products in this space right now. What's the current market size?
So the portable desalination purification market is $23 billion per year.
Okay, I'm confused. 23. That's a lot of money. Like
That
where
is
this-
the portability aspect means kind of the more large scale stationary, because it's portable. They bring it in on trucks. They can bring it into large areas. It is very difficult to pin down because of the flux of the market on how much small scale portable water desalinators are. That was part of our market research that we pushed very hard to try and find. However, that is because of government contracts, it's very hard to get some of this information out from the current contractors. Michelle.
So you talked about, the cost of filtering water.
Yes.
and the requirement of electricity.
Yes.
So have you done any thinking in terms of alternative markets like, you know, slums in Nairobi, you know, the middle of Mexico City where people need clean water, but they're not getting it from the tap? And maybe there are, you know, other models in place, but that are very expensive. Have you thought about looking at that? Oh.
Yes. So very quickly, most of those places need purification, which there are much cheaper solutions to, like LifeStraw and whatnot. Ours excels at desalination while also purifying at the same time, which is the added advantage of our product.
Thank you.
Thank you very much. Thank you guys very much.